Yeah, you're always wondering, why aren't people listening to me?
Just trying to make sure that we get the YouTube live stream going before we begin. I do see a few people piling in, so it's useful to wait. All right, so we have YouTube live now. So hi everybody, welcome to our webinar titled Securing IoT is a $6 billion Market. And we're specifically going to be talking about how Atsign is poised to dominate this market and beyond. So just a little bit of housekeeping before we begin. If you have any questions, if you're on desktop, you can go ahead and hit that little chat bubble with the question mark to go ahead and enter your questions. Or if you're on mobile, I believe you go to the window titled Q&A and you can enter your question there. If at any point during the live stream you want to see the speaker, there's the option to choose more, which is the 3 dots on your toolbar, and then you can hit picture in picture to enable that. Unfortunately, that feature isn't supported on iOS yet, so sorry if you're using iOS. And moving on, I'm going to introduce our co-founders here. So starting on the left, Barbara is our fearless CEO who successfully led and sold 2 companies and held several other leadership positions in prominent Silicon Valley companies. Kevin Nichols is our self-proclaimed startup junkie, and when he's not tied up on the playground, he's been on the leadership team of several very successful companies. And finally, we have Colin on the right. He's an all-around fun guy and our networking whiz, and he's invented a new internet protocol along with Kevin and other members of Atsign, and he's created the Atsign technology that has 38 patent pending claims. So I'll pass it over to Kevin now.
Thank you, Xavier. So just to spend a couple minutes talking about where this all came from. So this idea came about 8.5 years ago when Colin and I were having coffee in a startup incubator down in Silicon Valley, and we were moaning about the internet and how awful it had become, even back then, and we sort of decided, well, we should do something about it. And we were talking about it, and we had a couple of aha moments. So I hand it over to Colin for what popped into our heads.
Yeah, so we knew that it had something to do with identity, and we also knew that identity was very, very difficult. So the simple question one of us asked each other was, we can't remember who, was what is the simplest way to assert an identity on the internet? And it turns out it's actually really simple. It's just a unique string of characters, and these days we call that an ad sign. Now, 8.5 years ago, we actually started with putting together DNS and blockchain technology. We got something working, but it was pretty obvious to us that it wasn't going to scale, and so we sort of put it to bed, and we just waited for the right time. So fast forward to about 3.5 years ago, we had a relook at it, and we realized that some really major things have changed. And one of those was the devices at the edge of the network are now strong enough to cut their own cryptographic keys. And that changes everything. That means that you can now have secure communication because the edge devices have cut their own cryptographic keys. And the other major thing was that you could now have a directory of all of those ad signs because in-memory databases are now a thing, and they can scale to internet scale without any problems. So the only thing that was really missing was a protocol, a brand new internet protocol that could join those two things together. So that's what we started working on. And we quickly discovered that although the protocol is really, really important, not everybody wants to write in protocol level. So we started working on the platform. So Robert, I think you were the first to notice this problem. So.
Yes, being an application developer, I'm much more comfortable with much higher level stuff than you guys. So So after they built the platform, we started working with developers and trying to figure out where the best place was to go to market. And so we started working with consumer developers, and that went really well. In fact, we'll have some great consumer apps out on the market shortly. But what we found is a real problem out there that needs help right now is IoT. These IoT devices are proliferating very quickly, and they're not secure in the most part, and the data is definitely not secure. So we found a real need for this technology in IoT. So what is IoT? It's surprising what is IoT. It is just about everything that's going to be connected to the internet. And you may not think about things like cows, but farmers want to know where their cows are. And if somebody hacks in and finds the cow, poachers can easily go find out where all the cows are, and that's not a good thing. So all of these devices need security, and they need data privacy as well. So what is IoT? Xavier?
To get off mute before I talk again. So we're just going to do a quick little poll. We want to see how familiar you are with how many IoT devices are currently in worldwide use. So over in the webinar, if you're watching the recording, you don't get to vote, but we'll have everybody vote here just shortly. And so the options that are listed are 1.4 million, 144 million, 1.4 billion, and 14.4 billion. And so I think we have almost everybody voted here. We're just short a couple votes. All right, I think we're good to go. So we actually have a split between half of the people say 1.4 billion and half of them say 14.4 billion. But the correct answer is Barbara.
It's 14.4 billion and growing. So this is a huge, huge potential market. But the problem, as I was saying, is security in this market and people hacking in. And for example, Target was compromised because somebody hacked in through the sensors in the HVAC system. So putting these devices on the network is not safe in most cases. So the security market within the IoT market is also very large.
And so we're going to take it back to another poll. So we'd like to ask, how large is the IoT security market expected to be in 2023? And so I'll go ahead and hit that. And so the options here are 1.5 billion, 6 billion, 13 billion, or 33.2 billion. And that's dollars. I'll just give a few more minutes if anybody wants to get in a vote. Probably not minutes.
Yeah.
Okay. I'm going to go ahead and publish this. So we had one person say 6 billion, one person say 13 billion, and everybody else said 33.2 billion. And so I'm going to pass this back to Barbara to tell us what the actual answer is.
Yeah, you were all right at some point. But for today, it's 6 billion. But it will get there for sure over the next few years. So huge, huge market. So Colin, tell us about the problems with IoT security.
So as somebody who's actually had to deploy devices out in large enterprises, I can tell you that most of the IoT devices out there are very small, and yet the only solutions you've got are large and clunky and sort of enterprise class. But actually on the network itself, there's problems with IP addresses being static. So IP addresses are the addresses that are needed to get anything connected to the internet. Having a static IP address is basically just a findable target. So bad actors can attack your device. Having open ports seems to be always necessary for an IoT device these days, and that's just an attack surface. And the industry at the moment is talking a lot about managing your attack surfaces. So managing open ports needs firewalls, which that's even more complicated. And many of the IoT devices that we see today are really just working. They're not actually dealing with security and privacy. So that's really the key problems that we see with pretty much everything that's out there at the moment. The traditional services and the traditional solutions are just not working. You can go to the next slide. Thank you. Yeah, so this is it. Traditional services don't work. The traditional solutions are essentially two tools. They've been around for many, many years, firewalls and VPNs. Firewalls and VPNs you have to buy, so there's you have to buy them for starters. They're definitely using energy. They definitely cost substantial amounts of money, but really the capital expenditure on a VPN and firewall is only just the beginning. As somebody that ran a large network for a bank, the capital expenditure of firewalls was expensive for sure, but the operational expenses are far more expensive. They're expensive in terms of having people to run things, but they're also expensive in terms of having to change things. So change management, and you have to change things. And if you're managing firewalls and VPNs, there's ports to open, ports to close, everything's a change management. And each change management costs you even more people and more money. And it just gets really, really difficult. So these vulnerabilities are still out there. Firewalls and VPNs are really not the solution. So what we really are targeting is these problems for people that are running or trying to deploy IoT devices to make this far more simpler. So I'm going to hand back to Kevin to introduce what we're doing.
So it's typical for Colin and I guess we tend to try to go at problems at the source, at the root, and fundamentally try to change and simplify and fix things. So a lot of technology today is about automating things like managing and deploying firewalls and VPNs and static IP addresses and that kind of stuff. We took a different approach. Go to the next slide. So imagine if the world, if we had a technology that would make IoT devices invisible. So you can't hack into something that you can't see on the network. And our technology does that. So we create an environment where all the network services on the device are switched off. And even if the device has a private IP address and it's behind some other device, that means that you can't even see it, let alone try to hack into it. Next slide. So by doing that, we make them impenetrable. So if you shut off things like SSH access or the remote access into the device, then even if you could see it, you couldn't actually get in to do anything. And so we have so we literally flip that upside down. And so the device reaches out instead of somebody else trying to reach into the device. So if you say you don't ever need to have an ability to externally get access into a device, but you can still do all the things that you want to do in terms of administration and updates and so on. So by shutting off all those external services, we make the devices impenetrable, and the attack surface on the device goes to 0. You can't see it. Even if you could, you can't get into it. And then lastly, because we do end-to-end encryption, a lot of this is predicated on end-to-end encryption. Because we provide end-to-end encryption of the data at the data level, then even if worst case somebody got a hold of the data, they still couldn't do anything with it because it's encrypted with keys they don't ever have access to. So our key management is keys are kept and cut at the edge, and which means that there's no place to go and get a hold of the keys and get access to people's stuff. So even if you got a hold of the data somehow, you wouldn't be able to do anything with it because it's encrypted with keys you don't have. So, and that's just the beginning. So there are a number of other kind of benefits that come along with this. So Colin mentioned, the time and administrative overhead required for managing all the infrastructure, especially the security and all the change controls and kind of double inspection to make sure that, because there's a human element that still creates risk, then you have to have a lot of processes and procedures and honor those. And people are working really hard to do that better and better. But it is possible that to be able to do this in a fundamentally different way that solves that problem, which means that the deployment time can shrink from, sometimes we hear things that take 9 to 12 months, and that can be shrunk down to virtually instant. So we call it like three minutes or something, but it's essentially instantaneous ability to deploy. It also requires a lot less matter, a lot less hardware, and a lot less power consumption, smaller batteries, that kind of stuff. So the other benefits that you get with this is the ability to save energy and be more sustainable. And all those things together is a massive cost savings. And as Colin said, a lot of it is in the operational cost as well as the capital cost. So there's a very strong contribution to the cost effectiveness for customers. So, for example, so one of there's a great story around this, and there's some good YouTube videos out there. That there's a guy at a company called Zeriot named Jimmy Jones, and we started talking to him, and over a period of several conversations, it was kind of like, he had some ideas in his head, but it kept getting better and better and better. So if you look at Zeriot.com, you can see that they are just an amazing partner for us that are strongly endorsing this approach. The way they describe it is reducing IoT chaos, and this maps to DNA. So DNA maps exactly to how we operate in our solution. So it includes, it's securing things like the data, the network, and the application level. So it's not just securing the transport or securing the storage; it's actually securing at all levels of the application stack. And that's important, is a lot of the vulnerabilities are not necessarily just at the network layer and the termination points or exchange points along the way between endpoint to endpoint. There's a lot of opportunity for people to get access to data that they shouldn't be getting access to. And so we've done this. I remember Colin and I talked about this years ago. We had a dream that we could actually have the keys embedded inside of something that they could never be taken out of. And one good example of that is the SIM. So the SIMs, we're working with Zeriot and another company called Keegan, where we're actually cutting the keys inside of a SIM and then using the SIM to do cryptographic operations, actually do calculations, which means that the especially all important private key never has to leave the SIM ever. And in fact, can't be taken out or can't be copied out of the SIM ever. So that's the perfect storm for ultimately securing devices where there's nothing you could do to get a hold of the key for a bad actor that would give you access to the device and the data. And yet it's really easy to provision. So it's with Keegan especially, we're in Zeriot on their operations. It's preloaded with enough with an @sign and also a bootstrap key, not the actual final key, but a bootstrap key that allows it to be provisioned. And you can also deploy this out to existing devices. But Zeriot is a phenomenal partner, and I think you'll see more and more partners like Zeriot up on our website and our partner page, and solutions that are being built around this. But that's not all. So there's many more things that we can do with this technology. I'll hand back to Barbara.
Yeah, so if we zoom out a little bit, this technology is just amazing for lots and lots of different applications. We have a partner who's using our technology in healthcare for healthcare devices, and that really helps them when they're implementing their solution, it really helps them work with the IT department to reduce the attack surface on these things. So the one that we were working on last week, which was a lot of fun, was retail. And we just come up with some great ideas as to how to make the retail experience so much better. I mean, can you imagine going into a store and being able to tell people what you want or what you're looking for without giving any information at all? Everything's protected behind the outside, and you can take back that information at any point in time. It just makes the whole experience so much better. So we've been talking to people in telcos and 5G and smart cities, manufacturing. It just has really, really broad implications, and there's so much opportunity out there for this technology. Next slide. So this is how we see the future. Everything has an Atsign, and even those cows out there. So I think we can go to Q&A.
Awesome. Yeah, so please do drop any questions that you have into the Q&A section. So again, in the toolbar, you should see a little chat bubble with a question mark, or if you're on mobile, I believe it's a Q&A tab that you can enter.
Yeah, we really wanted to make this an interactive section, so we'd love to talk to you and find out what you're thinking. Or not.
So I guess I'll go first. I'll ask the first question. This one's probably best for Colin and Kevin, but what type of encryption do you use?
That's definitely Colin land.
So we use by default we use two types of encryption, asymmetric and symmetric, and the particular algorithms we use are RSA and AES. And for the techie amongst you, it's RSA 2048 and AES 256. However, the engineers have been working on something we call CHOPS, which is a cryptographic and hashing operations library, which allows us to plug in other algorithms. So if the customer wants to use another algorithm, and this was this is a good idea, full stop. But one of the reasons why we did it very recently was to use the cryptographic keys on the SIM card, which don't use RSA, and they use a elliptic curve cryptography. So we can show people that you can plug in your own cryptography, or ask another device to do the cryptography actions for you. In particular, as Kevin mentioned, the SIM card, or maybe a TPM. So we're not welded to any particular algorithm. We chose those ones because essentially they're pretty boring algorithms and been well tried and tested. If we did anything fancy, then I think it would be people would zero in on that stuff. There's not normally questions on RSA and AES, but if people want to use different algorithms, we'd love to know why, and get those working on the SDK for you.
Right. Thanks, Colin. So the next question we have here is from Kim, and she asked, what have the responses been when people understand the impact to their business? What's to take this one?
I'll jump in. So I mean, the two words we hear most often are game changer, and to the point where I remember one operations person in the electric industry who was dealing with changing configurations for electric meters, lots and lots of electric meters. And when we said you don't need to manage static IP addresses and VPNs and firewalls, he almost looked like he was about to come to tears, because he was just struggling so much with doing that. Literally But the most of his reaction is this is a true game changer that has, I'd say, a dramatic impact to their business in terms of especially speed and reducing cost, and at the same time delivering far better security than the way they're doing it today.
Thanks. And another question here from Dean is, by comparison, where are the large platform players in their security efforts in the IoT market? For example, Google, Microsoft, etc.
I'll take the one. So Google actually announced that they're getting out of the IoT market directly. So they're out. AWS and Microsoft do a really good job of having IoT hubs, and we actually interface with those pretty nicely. They do a really good job of displaying data. The catch is that where they are securing data, they tend to be securing data at the network layer, so using TLS to encapsulate data, and you still have the same old problems of sort of firewalling and VPNs because of that. One of the things you have to deploy to get many of those solutions out is either certificates at the edge, which is really painful, or VPNs, which again is really painful. So what we've been doing and what we've been seeing is people are still using the IoT hub for interpreting data and getting time series data, but migrating away from sort of painful bits of transport and moving Atsign to do that transport. So you're using our platform to get data to the IoT hubs that the big players are doing, and then you can display the data in there. The other advantage of using us for doing that transport is that you can send data to, or different subsets of data to different recipients. What often happens is, let's say you've got a bridge and you want to monitor the bridge, and there's 4 agencies that want to monitor the bridge. Currently, what happens is 4 sensors get deployed to the bridge and 4 networks get deployed to the bridge because nobody wants to share the data, and it's difficult to do that sort of cross-agency stuff. Using Atsign, you can have 1 sensor and encrypt data for each of the agencies. And some agencies want to have bits of the data, subsets of the data, and that's just fine using Atsign. So we work alongside AWS, the Microsoft IoT hubs, and there's plenty of other IoT hubs out there that you can see partners on our website that also provide IoT hubs. The biggest problem still remains is getting the data to the IoT hub, and that's a problem that we're really solving. But Kevin, I may have missed some stuff. Do you want to jump in with anything I missed?
I think so we've worked really hard to make the claim that it's provably true that we can't see your data, and all the other players are unable to prove that they can't see your data. In fact, they get kind of angry if you ask the question. But so in the end, we think that's the right thing to do, is for the hyperscalers or the platform providers should not be in the business of having a way to access your information. So we like to advance the idea that they should be able to not only claim but prove that they are not able to get access to your data.
All right. So the next question we have is by Noble, and it's, what has been the most surprising use case for Atsign technology?
My absolute favorite one, because we started with blockchain all those years ago, was to see a company called AdCrypto building a blockchain on top of our technology. This for me, that proves that we're a solid protocol. The underlying opinions are solid. I've seen this happen before. So when I was in the telco industry, the first IP packet I ever saw ran over a phone line. So I was using a modem. Nowadays, voice traffic goes over IP. So to see such sort of to see blockchain running over the top of our protocol within no time at all is super satisfying, and the use cases that our crypto can tackle because of our underlying technology are pretty amazing. So yeah, I mean, to see that was just phenomenal, and they're an amazing team and world-class developers. So they having them putting us through our paces has been an absolute joy. It really has been a joy. So I was not expecting to see a blockchain on top of our protocol, but super happy about it. Yeah, that's been the most amazing thing for me.
So you already answered this. Don asked, "Is this based on blockchain?" But which has already been answered. But as a continuation, Scott also asked, "I believe you mentioned that you're using a protocol. I'm curious as to why you didn't go with an API instead." So getting into more of the implementation, did you want to talk about that a little bit?
Kevin, you got to answer that. We've made you a convert.
Well, yeah. So I was sort of the API guy when we first started talking, and so this is we call it an argument. Colin and I tend to have arguments and then end up violently agreeing with each other at the end. So they're kind of fun. But so I was first saying it's got to be an API, it's got to be REST and all that kind of stuff. And in order to meet all the use cases that we wanted to meet, which is that it can run in anything, even really tiny things, we call it the light bulb test. So can you run our tech inside of really small devices like light bulbs and run them in huge clustered Kubernetes environments that scale up to 50 billion things, and everything in between. So that was part of the use cases that in order to make this sort of applicable across the board, you really had to do it at a very low level, which means the protocol. And I mean, we operate at the same level as HTTP, and it can work with HTTP as well. And but it had to be a protocol. And so I was wrong and Colin was right.
Just as once. And no, we're not based on blockchain. We did try blockchain in the early days, but we needed to build an internet protocol. And as I mentioned before, it's sort of cool to see a blockchain built on top of our protocol. But our protocol is not a blockchain. It's a plain old internet protocol using IP technology, TLS, and a bunch of verbs. So yeah, it's sort of low level stuff. And as Barbara mentioned, nobody wants to program in a protocol, so we had to build the SDK. So if you're a developer like our crypto team, you don't even know there's a protocol there. You're just running in sort of high level SDK stuff. It's yeah, but there is a protocol there doing all the heavy lifting for you.
And so the last question we have in here for now is also by Don, and it's how much can a company save in deployments? Who wants to take this one?
You did the math on that. You should.
Yeah, right. But as somebody who I used to work in telco, and I worked there for 10 years, and then I worked in a large bank, Credit Suisse, for another 10 years. I've had to deploy this stuff, and it's expensive. And if you remove the pain of all the administration work, you also remove a whole bunch of the costs. So in the calculations we've done, if you compare us with the traditional way of doing it, we're talking about 78% savings in terms of capital and ongoing expenses. And it's the ongoing expenses that kill you. So yeah, that just means you can deploy your IoT devices faster and get value for your business faster, which is sort of this flywheel effect that we're bringing to people. And that's why you have this this is the game changer conversations, because many of the IT projects that are out there have really been stalled because of cost, or just the fact that change controls just take forever. And they're very stalled. So we can get things actually moving and we can reduce the cost, which means you can double down on getting the IoT projects actually running. So, yeah, massive savings and massive opportunities for people to get going with their IoT projects.
Awesome, thanks. So at this time, we don't have any more questions, so I'm just going to give a quick last call for questions before we wrap up here. I don't think we're going to get any more because there was quite some time since we've seen the last one, so I'm going to move us on and wrap up. And so I just wanted to say thank you to everyone for joining us. We'll be posting our recording on our crowdfunding campaign page, and you can visit us over at republic.com/@sign. And I'm going to pass it over to Barbara to say a few words.
Yeah, so we want to thank everybody for joining. And on that platform, there's a question and answer section too. So if you think of something later, feel free to just drop it in there. And we're always happy to answer questions. So thank you so much for joining us today.